Welcome to this module on the Zscaler Zero Trust Automation Framework. If the previous module introduced what Zero Trust Automation is and what the individual API families do, this module goes deeper. It explains why the framework was built, how it works architecturally, and how you implement it correctly with real security and governance discipline. The three pillars we'll cover are one API, Z identity, and consistent automation patterns. We'll trace the complete journey from the fragmented before state through the unified solution and how one API works, into API client management, secure workflow design, automation use cases, governance best practices, and a side-by-side comparison of the old world versus the new. By the end of this module, you'll be equipped to answer exam questions that ask you to reason about automation design choices, troubleshoot authentication failures, and explain how zero trust principles apply to machine identities, not just human users. Before we appreciate the solution, we need to understand what problem it solves. Let's go back to the world before one API. In the traditional model, every Zscaler product, ZPA, ZDX, and client connector, had its own API registration process, its own token request flow, its own base URL, its own rate limiting strategy, and its own documentation style. For an engineer writing automation, this meant learning and maintaining four fundamentally different API environments simultaneously. This created four compounding challenges. First, fragmented API ownership. Different teams often managed separate credential sets for each product. This meant no one had a unified view of which automation scripts can modify firewall rules, or which API keys can create new app segments. Governance became nearly impossible, and security practices varied wildly across teams. Second, credential and token limitations. Managing multiple API keys and client secrets across products meant each had to be stored, rotated, and scoped independently. In practice, this led to overprivileged keys reused across scripts, because creating properly scoped credentials was complex, and to automation failures when product-specific token refresh logic had bugs or wasn't implemented at all. Third, rate-limiting inconsistency. Each product implemented its own rate limits and expected different back-off strategies. Bulk operations, like onboarding hundreds of branch locations, could hit unpredictable 429 errors that were hard to diagnose because the limits weren't documented consistently. Fourth, and most painful for operations, cross-product workflow complexity. An automation that needed to update ZIA policies and ZPA app segments had to authenticate separately to each service, handle different error formats, and coordinate failure handling across multiple independent calls. The result was brittle integrations that frequently broke in unexpected ways. This is the world the Zero Trust Automation Framework was designed to replace. The Zero Trust Automation Framework solves all four of those problems by introducing three architectural pillars that work together. The first pillar is Z identity, Zscaler's unified identity service. Z identity is the who layer. It manages the identity, authentication, and entitlements of every API client. When an automation script calls one API, Z identity is what determines who that script is and what it's allowed to do. Z identity centralizes all API client management and provides a single audit trail for all machine-to-machine interactions. The second pillar is one API, the unified API gateway. One API is the entry point layer. It's the single base URL for all automation traffic, whether you're calling ZIA, ZPA, ZDX, or client connector. It handles token validation, request routing, quota enforcement, and logging. From a developer's perspective, you write to one API surface. From a network security perspective, you allow list one domain instead of four. The third pillar is consistent patterns, uniform behavior for rate limiting, error formats, pagination, and logging across all services. This consistency means code written for one service can be adapted to another without relearning fundamentals. The framework's three key benefits emerge from this design. First, API clients become first-class identities, continuously verified, not just trusted once with a long-lived key. Second, there's a single control point for enabling, disabling, and auditing API clients, which is critical for incident response. Third, the framework applies zero trust principles to automation itself. Machine-to-machine interactions are subject to the same rigor as user-to-service interactions. Let's go deeper on one API itself. Its core purpose is to abstract away product-specific differences and present a single, consistent, secure interface. This is built on modern API gateway principles, centralized authentication, consistent request and response formats, and shared concerns like rate limiting, caching, and logging handled once at the gateway layer rather than in every client script. As a unified gateway, one API routes requests to the appropriate Zscaler backend based on the resource path in the URL. Your scripts send requests to one endpoint. One API figures out whether it needs to talk to ZIA, ZPA, ZDX, or ZCC. This means your automation code doesn't need to know about Zscaler's internal service topology, and Zscaler can evolve backend services without breaking your integrations. The 4 key features you need to know for the exam are these. Consistent authentication and token validation. Every request is validated against a token issued by zIdentity, checking the signature, expiry, scope, and tenant association. This supports centralized anomaly detection. If a token behaves unexpectedly, security teams can detect it from logs. Quota limiting and tenant access controls. Rate limits are enforced per client and per tenant, with 429 returned when exceeded. Critically, tenant isolation ensures that clients can only access resources within their own Zscaler tenant. There is no cross-tenant bleed. Caching and rest consistency. One API may cache responses for read-heavy endpoints, reducing latency from monitoring dashboards and analytics tools. More importantly, rest patterns are consistent across services. How you paginate a list of ZIA URL categories is the same as how you paginate a list of ZPA app segments. API documentation and developer experience. There's a single documentation portal with consistent endpoint schemas, authentication flows, and error code references. SDKs and code examples reduce the risk of implementation errors. And why is one API genuinely valuable, not just convenient? Because it extends zero trust to machine identities. Your automation scripts are treated as identities with explicit, minimal entitlements, continuously verified, not permanently trusted. This is zero trust applied to automation. Let's walk through exactly what happens when automation calls one API end-to-end. Step 1. Register an API client in zIdentity. You define the client, specify which API resources it should have access to, configure its authentication method, typically OAuth 2.0 client credentials, and generate a client ID and secret. At this step, you also assign the client's entitlements, which determine the scopes that will appear in its tokens. Step 2. Request a token. Your automation code uses the client ID and secret to authenticate with zIdentity's token endpoint. zIdentity validates the credentials and issues a JWT, a JSON web token, that encodes the client's identity and its permitted scopes. This token has a defined lifetime, typically short-lived by design. Step 3. Call one API. Your automation includes the token in the authorization header as a bearer token on every API request. The request also includes content type and any necessary path parameters or request body. Step 4. Validate and route. One API receives the request and validates the token, checks the cryptographic signature, confirms it hasn't expired, verifies the scope covers the requested operation, confirms tenant association, and checks that the client hasn't exceeded its quota. If everything passes, one API routes the request to the appropriate Zscaler backend service. Step 5. Backend response. The backend service, ZIA, ZPA, ZDX, or ZCC, processes the request and returns a response with an HTTP status code and JSON body. One API passes this back to your automation code. Now look at the layered policy enforcement model below the flow diagram. This is defense in depth for automation. Layer 1 is zIdentity, answering, who is this client and what can it do? Layer 2 is one API. Answering, is this specific API call permitted within the quota? Layer 3 is the backend service, enforcing product-specific business rules and constraints. The critical insight: a misconfigured or malicious automation cannot bypass these layers. The same zero-trust principles that govern user access govern machine-to-machine. Managing API clients through Z-identity is the operational foundation of secure automation. Let's walk through both the registration process and the credential handling requirements. The registration process has 6 steps. First, name and describe the client. Documentation matters because 6 months later you need to know what this client does and who owns it. Second, select the specific products and API resources the client needs. ZIA config, ZDX analytics, ZPA app segments, and so on. Not everything, just what's needed. Third, generate the client ID and secret, and immediately put that secret into a secure vault. Fourth, optionally define IP restrictions to limit where this client can authenticate from. Fifth, assign the minimum entitlements that match the automation use case. Sixth, document the scope and schedule periodic reviews, just like you review human administrator accounts. On roles and permissions, this is where least privilege gets practical. A reporting automation should get read-only access to ZIA and ZDX analytics and nothing else. A deployment automation might need write access to ZPA app segments, but absolutely should not have the ability to modify ZIA firewall rules. These distinctions are enforced in Z-identity through token scopes. Overprivileged clients represent exactly the kind of risk that a determined attacker or a buggy script can abuse to make unauthorized changes. On token and secret handling, 4 rules that must be followed without exception. Store secrets in secure vaults, never in source code, environment variables in plain text, or configuration files. Treat tokens as short-lived. Cache and reuse them until expiry, but never persist them longer than necessary. Implement renewal logic. Your code must handle a 401 gracefully by requesting a new token, not by hard-coding a static long-lived token. And ensure your logs never expose tokens or secrets. Include enough information for debugging auth issues without logging the credentials themselves. These 4 rules are the difference between secure automation and an incident. Building secure automation is about much more than calling the right endpoints. Let's cover the design principles and operational practices that keep automation safe and reliable. For secure workflow design, there are 5 key principles. Use SDKs or well-tested HTTP libraries rather than writing custom auth and retry logic. SDKs already handle token renewal, exponential backoff, and error parsing correctly. Validate inputs and outputs. Never blindly trust API response data before acting on it, especially for configuration changes. Implement dry run modes. Before enabling write access on a production script, test with read-only operations to confirm the logic is correct. Add approval steps for high-impact operations. Changes to firewall rules or bulk app segment creation should have a human review gate before executing. And limit blast radius through scope restrictions. Your automation should fail in a controlled, minimal way, not cascade unexpected changes across the environment. For monitoring API activity, you should track request volumes, error rates, and latency per API client, not just aggregate traffic. Set alerts on anomalous patterns, because a sudden spike in API calls from one client could indicate a runaway script or credential misuse. Conduct periodic entitlement reviews for all API clients. Requirements change, and scopes that were appropriate at deployment may be overbroad a year later. Decommission and used clients promptly. An orphaned API client with write access that nobody manages is an unnecessary attack surface. And when an incident occurs, correlate logs across Z-identity, one API, and a backend service to reconstruct the full picture of what happened. For troubleshooting the 3 most common errors. A 401 unauthorized means the token is invalid, expired, or the client doesn't have the entitlement for the requested resource. Check client credentials, token expiry, and Z-identity scope assignments. A 403 forbidden means the client is authenticated but doesn't have permission. You need to expand the entitlements in Z-identity. A 429 too many requests means you've hit the quota. You need exponential backoff and retry logic, and you should audit your automation for unnecessary or redundant calls. Let's go through the three major operational benefits the Zero Trust Automation Framework delivers in detail. Enhanced visibility and control. When all API access flows through one API and all clients are defined in Z-identity, you gain a single point for which to monitor, audit, and manage everything. You can see which automations ran, what changes they made, and whether they encountered errors across ZIA, ZPA, and ZDX from one correlated log view. If a script misbehaves, you can revoke its access immediately without impacting any other automation. This level of control is simply impossible with fragmented, product-specific API keys. Improved security posture. The framework applies the same security rigor to machine identities that Zero Trust applies to human users. Explicit entitlements, continuous verification, and minimal privilege. Scope short-lived tokens replace broad, long-lived API keys. When combined with automated rotation and revocation processes, this dramatically reduces the credential exposure window. And because policy enforcement applies consistently to both human and machine interactions, there's no backdoor through which automation can bypass security controls. Reduced human error. When developers work against a single, consistent API surface with predictable patterns, there are fewer opportunities for the kinds of subtle mistakes that cause real production problems. Using the wrong endpoint, misinterpreting a status code, implementing incorrect retry logic for one service but not another. Single model documentation and SDKs make it easier to onboard new team members. And configuration as code enables you to catch policy errors in a CI/CD pipeline before they reach production, and to roll back changes if automated deployments cause unexpected issues. For the exam, be able to articulate each of these three benefits and connect them back to Zero Trust principles, especially the idea that machine identities are first-class citizens in a Zero Trust architecture. Let's ground the framework in three concrete automation use cases that appear directly in the exam domains. Use case 1, configuration management across ZIA, ZPA, and ZDX. The canonical scenario is new application deployment. When a new app is deployed in your environment, an automation pipeline executes. It calls the ZPA API to create the app segment and access policy. It calls the ZIA API to update URL filtering and cloud app control rules for related SaaS dependencies. And it calls the ZDX API to configure monitoring probes for that application. All of this happens through a single one API session with one authenticated token. The result: policy and monitoring are perfectly aligned with the application change from day one, with no manual portal work and no risk of a monitoring gap because someone forgot to configure ZDX probes. Use case 2, reporting and data collection automation. Instead of manually exporting reports from the Experience Center, you automate this with scheduled API jobs. ZIA APIs pull security events, threat detections, and configuration risk data. ZDX APIs export performance metrics and ZDX scores. This data feeds into your SIEM for correlation with endpoint and server telemetry, and into reporting pipelines that generate executive dashboards on threat trends, data protection incidents, and digital experience quality. Automated reporting ensures consistent frequency and format without administrative overhead. Use case 3, integration with ITSM and SIEM tools. This is the closed-loop operational workflow. When a ZDX score drops below a defined threshold for a critical application, the ZDX API triggers creation of a ServiceNow incident ticket, automatically populated with path diagnostics, hop-by-hop metrics, and affected user details. ZIA and ZPA APIs can enrich that same ticket with policy and connectivity context. On the SIEM side, log streaming and API integrations give SOC analysts a unified view of Zscaler events alongside endpoint and infrastructure telemetry, enabling automated response playbooks. This is the pattern that reduces mean time to resolution from hours to minutes. Governance is what keeps automation safe at scale. Without it, automation can create exactly the kind of configuration drift and security gaps it was supposed to prevent. The policy as code and CI/CD pipeline shown on this slide represents best practice for zero trust automation. Policy definitions are stored in version control, just like application source code. Every change goes through a formal code review process where the security team can evaluate impact before approval. The CI/CD pipeline runs automated validation checks, syntax checking, logic validation, scope verification. Changes are deployed in stages: development first, then UAT, then production, with gates between each stage. And every deployment creates an immutable audit log. Who made the change, what was changed, when, and through what approval process. This approach is what allows you to answer the compliance question: who changed firewall rule X, and who approved it? That question cannot be answered if firewall rule changes are made manually through the Experience Center without a formal change management process. The governance checklist on this slide summarizes the non-negotiable rules. Use only documented public APIs, ZIA, ZPA, ZDX, and one API. Never attempt to reverse engineer private APIs. They're unsupported, undocumented, and out of exam scope. Assign least privilege scopes to every API client. Store all secrets in vaults, never in code. Handle every HTTP status code explicitly. Zero tolerance for silent failures. And here's the critical warning from the source material. Always deploy monitoring telemetry alongside policy changes, not after. If you push a large-scale configuration change without corresponding ZDX and logging telemetry already in place, you're deploying blind. Issues will impact users before you have the data to diagnose them. Conduct periodic reviews of all API client entitlements. Requirements evolve, and an API client that had correct scopes of creation may be overprivileged a year later as your environment has changed. Let's consolidate the before and after story into a crisp comparison across 7 dimensions. This slide is extremely useful for exam scenarios that test whether you understand the architectural problem one API solves. Authentication. Before, each product required a separate OAuth or API key flow. After, one zIdentity OAuth flow produces a token that works across all services via one API. Base URLs. Before, you managed multiple product-specific base URLs and had to allow list them all in firewalls and proxies. After, one API endpoint, one domain to manage. Credential management. Before, multiple API keys and secrets rotated independently per product, often out of sync. After, one API client and one secret, centralized and governed in zIdentity. Rate limiting. Before, each product implemented its own rate limits with different backoff strategies, making bulk operations unpredictable. After, consistent quota enforcement at the one API gateway layer with predictable behavior. Cross-product workflows. Before, separate authentication to each product meant coordinating auth and error handling across multiple independent calls, brittle and complex. After, a single token and session can execute ZIA, ZPA, and ZDX operations in one coherent automation job. Audit and visibility. Before, logs were fragmented across products. Correlating a full automation run required pulling logs from multiple places and manually reconciling them. After, centralized logging at one API and zIdentity provides a complete, correlated audit trail. Governance. Before, different teams managed different credential sets. No unified view of who could do what, and no single control plane for enforcement. After, all API clients defined in zIdentity. Single pane for least privilege enforcement and access reviews. Memorize these 7 dimensions. The exam will test your understanding of specific benefits of a unified model, and these comparisons give you precise, examable language to use. Let's close with a focused review of the 7 exam-critical questions for this module. 1. Why are APIs the foundation of Zero Trust automation? Because they provide programmable access to the Zero Trust Exchange's policy framework, configuration objects, and analytics, enabling scale and consistency that is impossible to achieve through manual portal operations. 2. What is the One API workflow end-to-end? Register API client in zIdentity, assign entitlements. Use client credentials to obtain a JWT from zIdentity. Include that token as a bearer token in every One API call. One API validates the token, signature, expiry, scope, tenant, and routes the request. The backend service processes and response. 3. What is the difference between public and private APIs? Public APIs, ZIA, ZPA, ZDX, One API, are documented, versioned, supported, and have compatibility guarantees. Private APIs are Zscaler's internal implementation details, undocumented for customers, and can change without notice. Never use private APIs for automation. 4. How does One API plus zIdentity simplify authentication and role mapping? Single API client registration in zIdentity produces one OAuth flow and one token that works across all Zscaler services via One API. Role mapping in zIdentity enforces per-client entitlements on every request. 5. How can ZIA, ZPA, and ZDX APIs combine for new application onboarding? One pipeline. ZPA API creates the app segment and access policy. ZIA API updates URL filtering and SaaS policies. ZDX API configures monitoring probes. All three calls use the same One API session with one token. 6. Why is centralized API client management critical for governance and least privilege? It gives you a single view of which automations exist and what they can do, enables instant revocation on incidents, enforces least privilege through scope tokens, and creates an audit trail for compliance. 7. How does the ZDX API support incident response when integrated with ITSM or SIEM? Auto-create enriched ITSM tickets on ZDX score drops, populated with hop-by-hop diagnostics. Feed events to SIEM for SOC correlation and automated containment playbooks. Closes the detection to remediation loop. The 3 core rules to carry into your exam. Public APIs only, never private. One API means one credential via zIdentity for all services. And enforcement is layered. zIdentity at the identity layer, One API at the API layer, and the backend service of the product layer. No automation can bypass this stack.